Okay, let's do sequences and series. We need to be able to tell the difference between an arithmetic or a geometric sequence or series. This is a sequence because we're not adding to find the sum of the sequence. So this asks us to find what is the 12th term of the sequence. So we have 9, 16, 23, and 30. We have an equation to find out some nth term, and it is a sub n equals a to the first, or a sub 1 plus n minus 1 times d. A sub n is any term that we want to find, whether it's the 10th or 11th or the 2nd, the 25th. A sub 1 is our very first term. This is plus what number of term that is that we're looking for, this number, whether it's the 25th or 11th, minus 1 times d, which is the difference. So what is our difference between these two terms, which should be the same as the difference between these two, which would be the same as these two terms, and so on. If it's arithmetic, the difference is the same between any two terms throughout the entire sequence. So we should see that this is 7. 16 minus 9 would be 7. 23 minus 16 would be 7. 30 minus 23 would be 7. So we can fill this out. 9 is our first term. We're looking for the 12th term. And 7 is our difference. All we need to do is simplify. So 12 minus 1, that would be 11. And then we're going to multiply that by 7. So what we have is 9 plus 77. So our first, or our nth term, our 12th term, is 86. So in another format, we want to find an nth term in a different sequence. And instead of showing us the sequence, they give us the first term, -4. They give us the difference straight out, which is 6. And then they tell us that n is 9, which means we must be looking for the 9th term. So we can use our same equation, fill it out, our first term, -4. We're looking for this 9th term, so we're going to do n, which is 9. 9 minus 1 times our difference, which is 6. So we just need to simplify. So 9 minus 1 being 8 times 6, which will give us 48. So -4 plus 48. So our nth term, our 9th term, is going to be 44. And kind of in another format, instead of giving us n straight away, they give us this a to the 20, or a sub 20. So we're looking for the 20th term, which means that this must be our n value. And we have our first term, and we have our difference. So there's kind of a couple of pieces of information here. This is our 20th term we're looking for. That means n is 20. So that is what we'll put in for n. We know our first term. We know our difference. We know our n value. We just need to simplify. So 20 minus 1 being 19. We're going to multiply that by -8. We're going to add that to 15. So 19 times -8. That will be -152 plus 15. We get -137. Now let's do something different. We're going to find what is called the arithmetic means for a sequence. So let's look and see what that looks like. We have -8, we have 4 blanks, and we have number 22. So we're wanting to find the arithmetic means. That must mean we're looking for missing terms. So I'm looking for missing terms. What do I have? I have an a sub n. I have a first term. If I have this a sub n, what is my n value? Well, I have a first term. I'm missing a second, missing a third, missing a fourth, missing a fifth. This is my 6th term, so I have an n value. Do I know my d? No, I don't know my d. So I must find that out, and that'll help me find those missing terms. So I can simplify all this. It gives me 22 equal to -8 plus a 5d because I have 6 minus 1. So I can just simplify all this. So move that -8 over, giving me 30 because I have 22. Got to move this over by adding. Now I can divide, and 30 divided by 5 is going to give me 6. So what does that mean I'm going to do? If my difference is, my difference is 6, then I am going to add 6 to my first term, and then I'm going to add 6 to each term thereafter. So 6 plus the -8 gives me -2. What's 6 plus the -2? It's 4. What's 6 plus that 4? It's 10. What's 6 plus that 10? It's 16. Now I'm going to find the sum of a sequence, which now turns it into a series because I'm taking each term and adding it to the next. I'm going to find the sum of this series, now turned into a series. So now I have a new equation. So the sum of a series, the sum of n terms of a series. So I don't know how many terms I have here. I know I have the first 3, and I know I have some maybe last number of the series. Since it doesn't go on, it ends here with 180. So that means I have n terms. I have my first term plus my nth term, and then all divided by 2. Do I have n? Do I know how many terms are here? No, I don't. I really don't know that. So I need to go determine n. I have an equation to determine n. So I know my first term. I know this nth term. I know d. 12, 19, what separates them? 7. 19 and 26, what separates them? 7. So I can go figure out what n is. So putting 180 in as my nth term, 12 is my first term. I don't know n, and 7 is my difference. So when I distribute that, I've got 7n minus 7. Here's my first term, my nth term. I can put 12 and the negative 7 together. That gives me 5. If I move that 5 over here, I'll be subtracting it. So I have 175 equal to the 7n, and then I'll divide that out. That gives me 25. So 25 is my n value. And now I can use that in my summation equation. So now I have an a sub 1, I have 12, I have 180. I do know my n value now, which is now 25. So I can plug that in. So I can do 12 plus 180, which will give me 192. I can multiply that by 25, and I can divide by 2. So 25 divided by 2, that gives me 12.5. So 12 plus 180 times 12.5, that gives me 2,400. Yay, I'm right. And that ends what we are going to talk about as far as arithmetic sequences and series.